Welcome, everyone, to another episode of IT Visionaries, and today we have a special guest. Normally, we have people on the work side, the employer side of business and technology. This time, we have someone on the education side. Meet Distinguished Professor and Director at the Institute for Data Science at New Jersey Institute of Technology, David Bader. David, welcome to the show.
Thank you, Albert. So glad to be here.
Awesome, man. Hey, listen, we understand that there's a lot of things happening at universities, for people who are distinguished professors, which you just educated me on, which is a higher rank than professor. So give our audience an idea of what it is you're working on. What are some of the current research projects you're working on before we dive into what you see in the world of data science?
Sure, Albert, great question. I'm so excited. Data science is this just booming field. And at NJIT, we have some amazing students. In fact, we just created a Department of Data Science and degree programs in data science. But in my research, we're really trying to create tools for manipulating massive data sets. So beyond what you could do with your laptop, imagine you had terabytes of data. With this ever-growing data, we're trying to make it more productive to do analytics on those massive data sets.
Yeah, I mean, totally understand that. Huge data sets. What we find out whenever we talk to people is people don't actually value the data nearly as much as they value the insights that are extracted from the data, some of the things that people are working on. You know, when we talk with companies that are in data science, they usually have very narrow occupational fields or use cases for what the data science needs to do, right? Whether it's a shopping company trying to match products to customers. Maybe there's employment companies trying to match jobs to skills. Give us an idea of some of the things that yourself and the students that you're working with are working on, because I'm sure you see a huge spectrum and wide array of projects that people are trying to computationally solve.
That's right, Albert. You mentioned recommender systems, and there's also a big booming area in machine learning, so trying to learn from data sets. But what we're working on is really getting insights and exploring data sets. Imagine someone hands you a big trove of data and you have no idea what's contained in there, but yet you want to pull some intelligence out of it. So we work in that domain. Often we're looking at, for instance, data that can be viewed as graphs where the entities may be represented as vertices and the relationships as edges between them, kind of like a social network, but on steroids. We're looking at very massive data sets. And the disciplines that we apply to are just ever growing. We look at health, personalized health and medicine. We look at cybersecurity applications. We look at urban sustainability. We even look at things like how do we ensure trustworthy elections? And so the use cases are just booming. Every company, every sector is going to want to be able to tackle these types of data science problems.
Give us an idea of some of the anecdotal stories of what worlds look like before and then what worlds look like after with data science. Because when we talk to our guests, obviously in the past, they usually they'll explain some interesting factoids like, hey, we have with this much confidence that we can recommend this shirt. It would improve sales by 30%. And that's a really cool use case. But the things you just kind of hit on, right? You're talking about political science. You're talking about environmental science. Sounded like there was a little civil engineering in there potentially. All kinds of use cases. I'd love to hear some of the things, because surely, and then if you have any stories of maybe projects that have gone to I guess the best way to say is gone to market, right? Projects that started in the classroom that were implemented in the real world, and we saw the real world after effects, because I'd love to hear some of these things that are happening, because that'll help frame up for any of our audience members who maybe thought data science was narrow to one specific use case or field, right? Like what I'm always afraid of is so many people are applying data science to advertising, which is obviously a big hire, like Facebook, Google. They definitely hire a lot of people. Usually you're going to be asked to try to find people, match content to people. Like that's generally what the big use case there is. But I love for our audience to hear some of these other use cases.
That's great, Albert. You see recommendations like ads or products, and these are very useful for monetizing your customers and getting more clicks through. But, if you serve up the wrong ad, nothing bad happens.
Yeah,
you just may not make a few pennies, but the world doesn't end. We like to work on a lot of problems where it does matter. So, for instance, we've worked on problems related to insider threats within organizations, for instance, lone wolf actors. And imagine that you have someone in your company who may be losing morale or maybe thinking about going to your competitor and wants to take your source code or your customer list. And this could be detrimental. It could blow the whole company. So, how do you identify that single anomaly, that single threat where you don't have a pattern of them before? It's not a recommendation engine, meaning that if you make a mistake and you miss this person, then that could be the fate of your company. So, we often work in those very, very hard problems. Another way to think about it is that recommender systems are strong correlations versus what we look at is data at the very long end of the tail. Often, this is the type of data that looks like noise. You may just throw it away, versus we look for signals within that noise to find that one tell, that one sign that may be leading to some egregious event or some very, very important matter that we have to attend to, depending on what discipline we're looking at.
Yeah, I'd love to hear how that's done, because this is where it gets really fascinating. I have a use case from a business that it was in the news today, and I used to do a talk on this, which is that the problem with data is, or in the past, the problem with data is usually people relied on some level of frequency or some type of volume in order for it to be relevant to them. And so I used the example, which happened, Spanx, for example, just got acquired today, or like this week, $1.2 billion. But Spanx didn't come from the hosiery industry. The hosiery industry didn't see it coming. Yet at the time when Spanx first started, if you had asked maybe not a data scientist, but if you would ask somebody, what's the trend on people wanting shapewear like this? The reality is the answer would be none. There'd be no data that says that they wanted shapewear. There might be a little bubble up of data points like, hey, there's a couple Google searches for shapewear, but hey, someone might ask you like, well, what's the total volume of shapewear searches a month? There might be 100. And then they'd say, well, how many people are searching for pantyhose or hosiery? It's like 2 million. It's like, okay, well, it's irrelevant. It's too irrelevant. So in the historical way we think of data as in frequency, volume, the problem with that is by the time it's recognizable or significant, the trend is already here. And that's a lot of things I know data science tries to do is stop things from becoming a problem. Like what you just said with a one bad actor, that person's, like you said, they don't have enough pattern or track record or history to suggest this. So how does data reveal that this is a possibility? How do you find significance in a small pool of data? I think that's something super fascinating. I'd love to hear like how this is done.
That's such a great question. And in our research, we're looking at getting to predictive analytics. Normally with data analytics, for instance, you may be a cybersecurity expert in your company and there's a breach and you collect up your system logs to figure out how did the attacker get in, what vector did they use, what data did they touch, what did they see, and what did they take? Perhaps what did they destroy? And this is after something bad has happened. What we'd like to do is look at streaming analytics and predictive analytics to be able to look at, say, network traffic and find that there is an attack underway in real time before it ever happens. So this is really a growing field. It's at its infancy, but something that we're very excited about. But let me just tell you another use case that we have for these large graphs. And you mentioned frequency counting. If you remember in the early days of Twitter and hashtags, there was a lot of analytics that looked to find heat maps or frequencies of hashtags, what was trending, etc. We were the very first group just over a decade ago to ingest all public tweets, the same tweets that were going into the Library of Congress, and create a graph from those tweets of the Twitter handle and the followers and followees. And we created a big graph and we looked at breaking events. For instance, this isn't the first pandemic that we've been in. There was the H1N1 scare and other pandemics. And we looked at what was happening on Twitter during the H1N1 influenza scare that was also predicted to have double-digit mortalities to try to find who was influential in giving us news on what was happening and how to stay safe. it turns out that we were able to discover through the graph, not just frequencies of counts of tweets, but through the graph connectivity and influence through an analytic called betweenist centrality that we were first to paralyze. We found the CDC, the US Centers for Disease Control and Prevention. We saw commercial media such as the New York Times, Time Magazine, and so on. But we also found very highly rated a Twitter handle you wouldn't think of tuning into to understand about a pandemic. And it turned out to be Official PAX. Now,
Okay.
I don't know about you. Do you know who Official PAX is?
No, but this is very fascinating right now. So you're saying like this official PAX is like a major source of information. Is this accurate? Like, is that what you're hinting? I'd love. Yeah, continue on. I'm fascinated.
So we're fascinated too, and we looked at who the heck is this. It came out in our top 3 handles for influential news about the H1N1 pandemic of fall 2009. And it turns out that it was a group of mostly adolescent males going to the Penny Arcade Gamers Conference in Seattle, Washington that year. And it turned out that they were the first group who got infected with H1N1. And they started tweeting with each other what the symptoms were, how they were doing, whether it was confirmed cases. And this was one of the most influential sources, one of the best news sources of understanding that growing pandemic. And if you're tuning in your radio dial, it's not who you would think to listen to. Nobody would have thought these adolescent males going to a gamers conference would be where you get your best information. So that's what we're trying to do with data science. We're trying to eliminate surprises and understand how to use data in near real time during breaking events in order to understand what is happening, what the situation is.
You know what you just said reminded me. So I went to grad school at Emory and got my master's program in public health. And I remember one of the courses I was fascinated by was actually epidemiology, which is reversing a disease state to find out like where did it come from, right? And so you're talking about being able to do this. I mean, it sounds like almost in near real time. Now, the coronavirus is obviously extremely virulent, right? It was extremely transmissible, but there was a time and place where it wasn't. There were things that weren't nearly as bad as coronavirus. Like if we had this data science, we could have possibly stopped it. Like I think back to like the E. coli scares where they were trying to backsource, like who was the seller of the source of food that caused these problems, and usually this requires a lot of people to get sick first before they start figuring it out, right? Everyone gets sick, then they go, okay, what did you guys all eat? And then they kind of backwards figure it out. Talk about how do you see these massive sourcing problems like epidemiology or recognition problems, like you said, cyber threats. How fast in the near future are we going to be able to, as data science, going to enable us to identify these problems? Like, do you see like near real time, kind of like as they're evolving? Is that the goal? Like, give me an idea of what's going to happen.
That is the goal. And Albert, you may or may not know that previously I collaborated with the CDC and Emory University when I lived in Atlanta, Georgia. And so
we might cross paths.
We might have. I used to go to the Kroger at Sage Hill. We probably crossed right there. So in looking at these problems, you really want to tackle them in real time. You don't want to wait days, weeks, or months. And I've been especially interested in food safety and security. In fact, there was a food scare, a salmonella scare in the United States. And for the longest time, for days and days, it was believed that it was the jalapeno peppers that people were getting at restaurants that was getting people sick. And I remember I was on travel and I avoided the peppers, but I had tomatoes. And it turned out that in reality, it was the tomatoes that had salmonella. And I caught a very bad case of salmonella. And so after that point, I became interested in how do we track food supplies and understand it's what's called an inverse problem. Once you detect all of these infections, you have to work backwards to understand the sources. And also food gets grown in fields. It gets brought to processing centers. It gets shipped and packaged and reshipped and distributed, etc. And it could take a long time going through paper records and logs to figure out what those sources are. if we could create a graph that maps that item from when it's grown all the way to when you're putting it in your mouth, then it would be fantastic to be able to work backwards. And we could do this very fast with a graph in seconds to understand the potential sources and then send investigators out to identify what may be happening at those particular sites. So what we try to do with data science is remove false positives. We try to take this big space that we're exploring and reduce it down to just a handful of things that a human, a person can investigate, whether it's a food outbreak or whether it's a cybersecurity intrusion.
So how is that done with, so, I think that's the big question that everyone that's not as familiar with data science always thinks about, which is, in the past, everything we've done when we try to do some type of study or to quantify something, it usually requires some type of statistical significance, right? Like, let's go back to your salmonella poison in the jalapeno peppers and the tomatoes. You'd be like, oh, 65% of people ate this. 85% of people ate that, and it's got to have some kind of density and frequency, kind of what we talked about, in order for there to be a signal to say, okay, this is happening a lot. It's repeatable enough. I think this is the source problem. What's interesting about data science is we're talking about using it sounds like other variables, other factors to try to identify how important or relevant a single data point can be, so that you're saying, hey, I don't need to wait for salmonella to sicken 1,000 people. Within the first 5 people, I might be able to start finding the sources, or the first 6. I don't know what the number is, but less than what it used to be, right?
That's right.
What are some of what are, I guess, the evaluation criteria that's going into this? Because this upends everything we've ever thought about how we quantify things.
That's right. So traditionally, we would just look at hits, for instance, hospital intakes, to see if there was a significant set of patients. And then if it reached a particular threshold, we would sound the alarm bells. But now with data, we have many different data sets that we can start to convolve together and build relationships among the data sets. Essentially, that's what that's doing, is putting that data in context. No longer are you just a person who presents at a hospital with a fever. Instead, we will start to understand you ate the following meals at these restaurants, you visited the following locations, maybe there is something in the environment, and we get to have a very clear picture around, say, that patient that may give us more confidence that we're onto something, rather than what we did in the old days, which was really just a paper and pencil exercise.
So you're collecting all these variables that are related to the record, I guess is the best way to say it. Ancillary data points, evaluating all of these things together. Well, I guess how much confirmation do you need before in modern data science, where it can say, like, hey, we have with some level of certainty that this is happening? Does it have to match a previously existing pattern? Like, how does it work? Because I think this is what, it boggles my mind. I'm not that smart, but it boggles my mind, where I'm like thinking, hey, if you have a case of one, like you kind of used an example earlier about the person that's about to go rogue and possibly take all your information. Let's put me in a big time company, right? Let's say I'm a big time company. Like, I'm one of the government contractors. I'm like BAE Systems. Or Northrop Grumman, Lockheed Martin. We make high grade defense weapons for the government. And I don't have a record of, like you said, I don't have a record of this person going rogue before. I also don't have maybe a record of a person going rogue in the last, let's say, 5 years. So what signals are being evaluated, or how does something get evaluated where there's only a record instance of one where it's still statistically relevant? I guess that's what throws my mind off. I'm like, I don't see how that's possible, but you guys are figuring it out.
Well, that's such a great question. And I think the real answer is that it's going to depend on the problem space. But let me just give you an example. There are many cases where we've had lone wolves. For instance, at Fort Hood in the United States, a number of years ago, we had Major Nidal Hassan, who was a cleared Army psychologist who one day came in and killed a number of people. And before that, he had never been there'd never been any issue. There's no disciplinary issues, etc. And we weren't going to wait for statistical significance with lone wolves. For instance, you don't want to wait until after an event like that happens.
Right.
What you want to be able to do is give a security officer some heads up that we think this person's pattern of life has changed. Maybe you should do another investigation. For instance, Major Nidal Hassan tripped up not just one, but two Joint Terrorism Task Force tripwires. He was communicating by email with a terrorist, an American-born terrorist in Yemen named Anwar al-Awlaki. And in those communications, every time he was asked, he said, oh, well, it's just research that I'm doing, rather than, hey, I'm being radicalized by this American-born cleric. Had those two investigations known about each other, this was in a Webster report about the event, we would have been able to have such insight that, no, something has changed. He's been radicalized and now is up to planning for some egregious event, which he ultimately committed. So in many of these cases, what we're really trying to do is enable a human analyst who normally would be overwhelmed. If I looked at all the people sending email outside this country, well,
right.
I'd be overwhelmed. But if I can find the one person that's communicating multiple times in multiple ways with a radical terrorist, then that should be something that I pay a little bit more attention to. And so I think that's how these techniques may help, whether I'm trying to find a better outfit that fits me from fashion, or whether I'm trying to find a better commuting route with less congestion on my path, or trying to find some person who's up to no good who works for me and is about to delete all the source code to the company or make public all of our internal communications. Those are the events that we're hoping to look into.
Give me an idea of what it's like when in regards to enrollments or interest into this field, because we obviously hear it from the employer side. Most of our guests are employers of data scientists. They always talk about lack of talent, not enough people are in this field. It feels like there's probably a huge wave of, I call them kids, but I call anyone who's younger than me a kid. Probably a whole wave, I guess, of college kids attempting to learn and study this. What does that look like in regards to like enrollments, interests? What's it like for these programs? Because this is something clearly that's not going to go away. And clearly the demand is just going to go through the roof. Every company, as you just suggested, from fashion to, national defense, is going to want some form of insight from data.
That's right. And what we're seeing is a boom. This is similar to what happened in computing 20 years ago as the world digitized. But in data science, every company, whether you're in the financial sector, insurance, health, if you're in entertainment, fashion, transportation, every single sector now is collecting data, more and more data every day than the entire history of all of the data collection. And we're seeing very clear benefits of being able to improve companies, do better customer retention, improve products, make decisions that are all data-based, data-informed. When I look at the US Bureau of Labor and Statistics, we see data science as one of the hottest fields. In fact, the biggest region right now is where I'm at with New Jersey Institute of Technology in the Newark to New York City area. Is one of the hottest regions because we have so many sectors that are just searching for data scientists. We launched a program very early, about 2 years ago, in Jersey City to train master's students and give certificates in multiple areas of data science. And we saw the program oversubscribed. We had students coming who were working in fintech, they were working in power companies, at banks and other places, really just pushing for learning data science so that they could be more useful in their workplace. Since then, we just this semester launched a bachelor's degree in data science to go along with our master's. And by next fall, we plan to have a PhD in data science. Again, the students are coming out of the WordWorks asking for these degree programs, and the enrollments are increasing. And we see that as a national, potentially international trend, that data science is in such high demand. But the students are doing it because the jobs are there. The amount of postings, if you look at LinkedIn or you look at Glassdoor, these places are just filled with searches for data scientists.
Give me an idea of what like the people that are graduating or even about to graduate your program are saying in regards to like job hunts. Like, is it for them? I bet you for them, it feels like they're being recruited, huh? Like everyone's hitting them up every single day. Like, hey, work for me, work for me, work for me. Is that what it's like right now for them?
That's right. I have students, one just went to work at Facebook. They get offers from companies like American Express and JP Morgan Chase and lots of different companies. But whenever they go out on the market, they find that there are so many options for them. The amount of talent that we're producing, it's like a new pipeline, and it's just filling up with students right now. The companies that are searching, we have, for instance, an Institute for Data Science that I direct. And on my board, I have companies such as Google and Amazon, Stanley Black& and Decker, Yahoo Research, Neck Labs, UPS, the New York Times, on and on. I have companies that are just really searching for this next talent. And I think that we're going to start seeing more and more programs that are emerging. Right now, universities are just getting started to create these programs. There are discussions about what should this program contain. It will be a mix of computing and mathematical sciences, applied statistics, data science technologies. And as we create more and more programs, I think we're going to see in the next 10 or 20 years a continued growth for jobs and employment and thus training in data science.
Curiously, how many universities currently offer programs like this? Do you have any idea, like a ballpark?
I would guess at this point there's probably dozens of universities, of the
Dozens.
thousands. There are dozens that are offering programs. Now, some data science may be a certificate. In others, it really may be a thrust within, say, a math department,
Yeah.
and so on. So the naming is starting to change. But we're very early to create a department and degree programs that are called data science at the New Jersey Institute of Technology.
But what you just said though is wild to me. You said dozens, which is very small, right? There's literally thousands upon thousands of universities in the United States alone. We're saying only dozens of them have data science. Kids, it sounds like students want this. They know the opportunities there. You're already saying, you sit at the head of NJIT and you're saying, hey, the amount of projects that are coming forth that people are trying to research, you're saying you could clearly tell people have interest of applying data science in every spectrum you can think of.
That's right. That's right. We talk with so many companies and also government, and we're trying to create industry academia partnerships to be able to solve many of those problems. And the demand is just huge. We're a pioneer in this area. We're really leading the way, and we're trying to encourage other universities to move into this space. Universities sometimes have a reputation of moving slowly.
Yeah.
And so because of that, we decided that we really had a need. This region that we're in is just growing, and data science clearly is in the future of every company in every sector, and we took a leadership role. We're also a part of some consortium. For instance, the Academic Data Science Alliance is a great way for universities and data science leaders to come together to talk about creating such programs and looking at what programs have already been created around the company, around around the country.
All right. Well, give me an idea. Like, so, because a lot of our listeners we know, so our listeners are split into just a couple buckets, right? Some are already at the executive leadership position in companies. Others are like ascending to that level, and others are just starting in their career, right? Those are the three buckets of tech listeners we tend to have. If someone is in programming, let's say they're already an adult, they've already finished school, they're programming, they're working in tech, maybe they're not, maybe they're thinking about working in tech, but now they hear this talk and they're like, man, I agree with Dr. Bader. I want to get into data science. What do you recommend? How should they begin? Certainly there's a lot of prerequisites someone needs to have, I'm assuming, before they enter your program. Give us an idea of what I need to know, because I'm thinking to myself, like what level of math do I need? What level of computer knowledge do I need? Like, I'm sure, like you mentioned, you have to know a little bit of both for sure. Give us an idea where should someone who's thinking about going into this field start?
So that's a great question. And I think, for instance, you could search YouTube all day finding videos to learn about data science. Perhaps it's one of the most popular themes for tech talks around YouTube these days. But there, I would say, two types of data scientists. There are going to be those that are creating methods and really coming up with fundamental new techniques. And they're going to need a deep knowledge of algorithms and mathematics, especially applied statistics and other foundational techniques. Then,
That sounds like next level. If I'm creating methods, I'm thinking I'm next level until that's you. That's your job, Dr. Baker.
correct. That's right. And my students and I are going to be very delighted. I would love to create algorithms all day. This would be my sweet spot. But then there are going to be data scientists who are going to be working with data sets. They are handed a big hard drive at their firm and told, tell us what information you can pull from this. Now, those data scientists are probably going to be using frameworks such as a Jupyter notebook. They're going to be programming in Python. They may use some packages like NumPy or Pete or Pandas and be able to manipulate these data sets and pull out reports and analytics. And I think that's where probably 80% of data scientists are going to live. In fact, just recently, Python overtook languages like C, C++, and Java as the top programming language. And we think of Python as sort of the lingua de franca for data science. So if you want to talk data science, you often are writing in this very productive high-level language called Python that I think anybody could pick up and learn.
Listen, when I worked at a tech company in 2017, we wanted more Python engineers. I can tell you that they were very hard to find. And we were a relatively small startup bidding quite a big number on wages against some of the biggest players. So it was in demand in 2017. I can't imagine what the demand is now for Python knowledge.
Oh, it's huge. I mean, back decades, it was COBOL. Today, it's Python. So we're just seeing this huge demand. And there's also a lot of recipes written in Python. There's a lot of examples. People run competitions, for instance, the Kaggle competitions, to look at analyzing data sets, and then they share their Jupyter notebooks of what they did. And so if you're getting into data science, my biggest recommendation is to pull a data set that you find, for instance, at a Kaggle competition, and try to run the examples, try to do the analyses, and that will put you in a perfect position to be able to get a data science education and an even better job playing with these data sets and getting paid to do so.
No, that is super awesome. As we come to the end of our time on this show, I want to ask we ask some more fun, looser questions before the lightning round, which is coming up. But this is about work. So this is still part of the core interview. David, you have such expertise and you have such insight into different, projects that are happening. I'd love to bring up some problems that the modern world is facing. And I want you to tell me how fast, what is a way that data science could possibly help that problem. All right. You think this would be a fun exercise? See if you can stay on your toes. All right. So I'm just going to name problems. Ready? This seems like an easy one. Logistics. Shipping containers are backed up across the country. They can't move them off boats fast enough. How could data science help that?
So data science could understand where all these shipping containers sit, and rather than solving a problem locally, could look at globally all the shipping containers, the shipping routes, and the ports, and better optimize how those containers are offloaded and transported. It would also be more fuel efficient as we minimize the movement of those containers, both in offloading and onloading. So that's a great problem for data science.
How about traffic jams?
Traffic jams. If we had a nav system that didn't just find us the shortest route, but was able to look at all of the traffic and give us alternate routes that would eliminate these congestion points, another great place for data science.
Understaffing, or I guess overutilization in hospitals. Understaffing in hospitals. We keep hearing about how because of COVID-19, there's a lack of hospital resources available to people who are, let's say, non-COVID, right? Like that's been clear that's been a problem for a lot of areas, very much locally.
So that's a great instance because hospitals may be able to use data science to track their supplies. They may have a separate system for staffing and then a separate analytic for understanding COVID and infections within the region. But data science could bring all of these together to give better situational awareness and to be able to have the right staffing and the right resources at the time when it's needed. And bringing these different data sets that often are in their siloed systems all into one view.
Yeah, that's definitely been a problem. We keep continuously hear about the healthcare system as most of the data is contained within the hospital walls. No other hospital can learn from what's going on, even one that's just literally down the street. And so
that's right.
They run into conflict.
I mean, imagine that you really had that situational awareness of everything around you. You would make better decisions, and you'd also be able to learn what's happening and do this in the speed of light. In data science, this doesn't require humans sitting there to analyze paper printouts. You have all of this information that could readily be used to improve the situation.
Awesome. David, I want to say thank you for joining us today on IT Visionaries. But before you go, now it's time for the lightning round. We did a little pre-lightning round. That was a lot of fun because you have just such unique insight. The lightning round is brought to you by Salesforce Platform, the #1 cloud platform of digital transformation of every experience. Dave, this is where we ask you questions outside of the realm of work so that our audience could get to know you a little better. So you've shared quite a bit about your career and teaching and data science, but now we want to know about David, the person outside of data science. You ready?
I'm ready.
All right. So we mentioned we crossed paths in Atlanta. You were at Georgia Tech for a while, and while I was at Emory. What made you, this I guess a little bit of a career switch, but what made you change to go from Georgia Tech to New Jersey?
I was really interested in getting to a hotspot of the company where there was tech innovation, and New York City and the Newark, New Jersey region are the biggest source for companies dealing with data sets. And so I came to build more partnerships between industry and academia.
There you go. New Jersey and Atlanta, or where you are, Newark especially, it's right outside of New York City. Obviously a huge place. Atlanta's a huge place. But what is one major difference you've noticed about the two? And don't say the weather.
Oh, one noticeable difference. I think. That's a stumper question. I feel like home here in the Northeast.
Do you?
I do. I grew up not too far from here, so it's a homecoming.
One of the things that's interesting about your field in academia takes you to a lot of places. We see that you've been to you taught at University of New Mexico. You've been University of Maryland. You've been at Georgia Tech. You're now in New Jersey Institute of Technology. I didn't say all the places you've been, but to give. What is that? How would you describe moving so many different places throughout your career?
So
Has it been fun? A pain in the butt? Like, how's it been?
Oh, it's been great. So one of my first academic positions at University of New Mexico, I created the first Linux supercomputer, which is why I'll be receiving the IEEE Computer Society Sidney Fernbach Award next month. And
congratulations! I don't know exactly what that is, but it sounds impressive. It sounds awesome.
I got to work with Sandia National Labs and Los Alamos National Lab. It was the hotspot for high performance computing in Albuquerque, New Mexico. So I enjoyed that very much. But moving around, you work with new partners, you make new friends, and it's been a fantastic ride.
That's awesome. What do you like to do outside of, so don't say anything computing, don't say anything about data science. What else do you like to do for fun?
For fun, I follow around the Grateful Dead, or what's become of the Grateful Dead these days. I listen to a lot of music and folk music, as well as some jam bands and classic rock.
All right, I feel like this breaks very much a big stereotype. Are there a lot of other Grateful Dead heads in data science?
There are several who shall remain anonymous. Look at one of my Grateful Dead shows I went to back in the day with Jerry Garcia. I was right there with Al Gore Jr., who is a vice president later, and I've seen some great people at these shows. In fact, well, I'll just leave it at that. Sometimes some things should remain unsaid.
There you go. Hey, listen, I understand. David, I want to say thank you for sharing a little bit about your personal life. Thanks for sharing what you're up to in data science at New Jersey Institute. Excuse me, let me say that again. What you're up to at New Jersey Institute of Technology and some of the research, and congratulations on the award you're about to receive. I couldn't rename the award without listening to it, but I tried writing it down. It sounds impressive. It's awesome. You've been a fun guest. I think you bring valuable insights, and if anyone is curious about data science, follow David's recommendation. He says you got to get into it. It is high demand occupation. Basically, I don't see it going out of demand. And is this going to be a field that's going to go out of demand in the next 20 years? I don't see it.
Not at all. We're going to see this grow and grow.